Okay, so we have our hypotheses and we have our predictions. We have to design a study. Okay, we design an experiment. We're going to solve the question of causality. An experiment, and this is your textbook definition, you'll find it in your textbook, a deliberate manipulation of a variable to see whether corresponding changes in behavior result. Okay, so we have variables here are television and social cognition. We can vary television by having people watch TV dramas, documentaries, or not watch anything. Or we could have them watch whatever, but in my example there's only 3, right? Operationalization, okay, is the specific definition of a variable that allows it to be measured. I am operationalizing TV viewing by having 3 groups: drama, documentary, and control. Okay? Operationalize social cognition by having people look at a whole bunch of pictures of eyes and guess what emotion is expressed in those eyes. So to operationalize something means just turn it into something that can be measured. Happiness. We talked about happiness. To operationalize happiness, people will fill out a scale that says, strongly agree to strongly disagree. You've seen those things a million times. I am very happy today. I am not so happy today. Series of those. One way to operationalize something is to have people take a little quiz. It's called a self-report measure. Variables. So I've already talked about them. A variable is something that can vary. And here's your textbook definitions. Independent variable is the one that's manipulated. That's the one the experimenter changes to see if there's an effect on the dependent variable. On our COVID cure, it's the new drug versus the no new drug. Okay? The one that's manipulated or changed. In our example, types of TB, dependent variable is the one that's measured, also called the outcome variable. The dependent variable is the one that we assume is being caused by the independent variable. The independent variable is assumed to cause, the cause. This is the one that's being caused, the effect. Cause, effect. Is that clear? Make sure I tend to get going fast. If I do and you have a question, just raise your hand and stop me. Any questions so far? Remember, I think I mentioned last week that taking notes by hand, I don't know if it's in this class, is actually more effective than taking them by computer. So in that experiment, say a researcher wants to know which leads to better learning outcomes, taking notes by hand or taking them on a laptop or tablet. Can anyone tell me the independent variable in that example?
What you're using.
What you're using to take notes. Correct. A tablet versus a pencil or pen. And what could be a good dependent variable?
Grades, output.
Yeah, outcome. Grades could be a good, anything other than grades?
Outcome of notes.
Example, what was that?
The outcome of the notes.
Yes, but how would you measure that? How would you operationalize that? One suggestion was with grades.
Actual knowledge of what was taught.
Memory, you could do a little memory test. Knowledge, which that's good, but then you have to operationalize that knowledge with like a grades in the class or a test, something like that. So good. So you guys get the idea of the difference between independent variable and outcome variable. All right? Okay. So, in the example, type of TV show. This is Mad Men. It's award-winning drama versus a documentary. Both of these are good shows. Okay. When it comes to independent variable, and I kind of talked about this already, you have independent variable groups. You have the experimental group, subjected to the independent variable. Okay, so that could be watch TV, receive the drug, take notes on the tablet, or take notes by hand. The control group are not subjected to the independent variable. You might see placebo, so placebo for the drug. Maybe they don't take notes at all, they just sit there and watch, or do the professor a great favor by filming, so you can therefore watch it later. Okay, control group in our example, no television. Okay. An essential part of an experimental design is random assignment. Now, we just talked about random selection to get a representative sample. That's when I was given that example of 2 students. In an experiment, you have to randomly assign participants to one of the conditions or groups, okay? Assigning people to experimental control groups randomly so that each subject has an equal chance of being in either group. It controls for confounding variables, such as preference for types of TV show, personality, pre-existing ability at social cognition, because some people are just better at reading people than other people are. So the idea of random assignment is everyone has an equal chance of either seeing drama, documentary, or nothing. That's supposed to get rid of the confounds, okay? Now, it doesn't always work perfectly. So we also test. We usually have, if there's a pre-test, post-test design, you do ideally you might do pre-test social cognition before and post, and you control for pre-test scores when you do the statistical analyses of the post-test, which is after you watch the things. Okay? So, how many people's favorite TV genre is award-winning drama, is drama? One person likes drama. Who likes crime shows? Procedural stuff. Yeah, a lot of people like that. Who likes science fiction best? Yeah, me too, actually. Well, might be fantasy. Fantasy? Okay, romantic comedy? Yeah. My boyfriend's favorite thing is romantic comedy. It's so weird. You think that it's like a stereotype that men don't do that, but he likes romantic comedy. It's so weird. What other kinds? Sitcoms? I actually really love sitcoms. I'm rewatching Seinfeld for the 50th time. I can't remember any other genre. And did I skip someone's favorite genre? Which cooking shows?
Yeah.
Oh, that's a thing too. People love. Oh, and the what do you call it? Like survival shows. God, there's a word for that. I don't remember. Anyway, so that could affect whether or not you respond to the independent variable the same, right? You know, some people love documentaries, some people don't. If you see a documentary and you go, through the wormhole is really great, so you wouldn't think you would sleep it, but they might. Okay. Random assignment is essential. In our example, here's the dependent variable. Social cognition, theory of mind, understanding emotions. So the way I operationalize it, you can barely see these eyes. By showing people a whole bunch of pictures of eyes. Okay, this is called the reading the mind and eyes textbook. So, and then there would be 4 words under them, and participants would have to say which of the 4 words best describe what the person was feeling. So how many people think that this person's feeling playful? Comforting? Irritated? Or bored? It's too bad we don't have back lights, because what I like to do when I'm teaching is have these ones lower and those ones strong, but yeah. So, oops. This one is playful. So you guys almost did. There's 36 of them. Okay, so potential issues. Placebo effect, okay? Expectations of participants can influence their behavior. We just talked about the placebo effect. That's when you take that sugar pill and you think it will get better anyway, right? On the other hand, we have the experimenter effect. And that's the tendency for experimenter expectations to influence the results. Okay? So, how can we deal with this? We can use we blind the study. So what you call it as a blinded study if one or both of these is true. So a single blind study, that's when the participants do not know what group they've assigned to. So they don't tell you when you participate in medical research, they'll tell you you will either get this, that, or the other, but they don't tell you which pill you're receiving. You don't know if you have the drug or if you have a placebo, right? This reduces the placebo effect because you can't know. However, this does not reduce the experimenter effect. So the double-blind study, neither the experimenter nor the subjects, the participants know who's in what group. This reduces both effects. Okay? Ideally, studies are double-blinded. However, it's not always possible to do this. So, what are some other solutions? Don't analyze the data until data collection is done. Now, why, I'm mentioning these because there's been a lot of people question science because I'm a psychologist, this is psychology. Starting around 2015, they did this huge thing where they tried to replicate, that means repeat the same results, doing the same studies that have been done historically in psychology, those foundational studies, and a lot of them failed to replicate, okay? And part of it is because people were not good about following these things. So some ways to deal with these effects of experimenter bias: don't analyze the data till data collection is done. Clean the data before analyzing. Cleaning data just means getting rid of bad data, okay, or fixing things that weren't correct. Like when there's data entry, when that person actually has to put it into the computer, there's a lot of potential for errors. Because, for example, if you need to put a 5 in, you can accidentally do 55. If you ever do stats, you'll learn more about this, but it's important. Clean the data, that means determine what data is good without knowing what group it belongs to. So say, for example, in the television and social cognition, maybe I think, well, I have to do something about really high scores or really low scores. And maybe I kind of want it to be the case that people who watch drama do better and people who watch documentaries do worse. So I might, without even wanting to bias my results, I might have this tendency to think, oh, that's a high score. And if I know it belongs to the drama, I might be more inclined to keep it than if it belongs to the other one, right? I might unintentionally bias it. So when you clean your data, you should never know what group each person belongs to. Okay, that helps. No peeking. Best to have a statistician who has no idea what's going on analyze the data. That way you can't possibly be any bias there, right? Okay. If supposing you collected the data without bias. Remember the playground example? If you're looking at the playground, you want those people taking notes and counting the times that children do things to be also blind to the research question hypotheses. Otherwise, they might not count things that don't go along with the hypothesis. Does that make sense? This is what doing science means. It means tricking yourself so your own biases don't get in the way. And it is hard, and you gotta do it, right? Okay, so we've done all this stuff. We've collected the data, etc. We have to test the predictions. Okay, when you test your prediction, you have to think of the logic behind it. If watching good TV improves social cognition, the participants in the experimental group will do better on the ICE test than those in the control group. So we test that prediction with statistics, which this isn't statistics course. It was the case that this was true, the hypothesis was supported by the data, and then you should draw some inferences. So the final part of that little circle, the research method, is draw inferences. The inference here was fiction and film can improve social cognition, or anyway, it can make people better at, looking at pictures of eyes and figuring out what emotion's in it. But then you have to question it, right? Again, is it only award-winning fiction? I bet romantic comedies would also have a similar effect, or crime dramas, because all that mysteries and stuff where you have to really think about the intentions of criminals and everything, maybe that will work even better. as watching Don Draper. So when this study came out, it was all over the press. And there's actually, like, I think maybe it was Business Insider or something said that, you know, watching Don Draper makes people better at mind reading. First of all, we weren't measuring mind reading, and secondly, no. But anyway, think about it. Maybe it's just because fiction is about relationships and watching people interact primes us to pay attention to expression. Priming just means makes it more likely that you're gonna notice a certain something, right? Priming makes it more likely to do something. You could think of alternative hypotheses. And then it all starts again. So I think I have to circle. So that example, we went all the way through it, we got to the draw inferences, and that's where you start wondering, is it really award-winning fiction? And you may be gonna generate some more questions. These are the generating the questions, and a good follow-up study would be maybe, you know, looking at popular, romantic comedies, okay? Crime shows, doing the same kind of thing, or maybe using a different outcome variable. Instead of eyes, maybe you'll have people read little scenarios and take a little test on the intention of the characters, right? Somehow we can expand it, and it goes round and round, and we get more and more evidence. Any questions? Okay, so before we go on, you can pause, turn that off for a second.